Children, in this video, I would like to demonstrate how to find out the SCF of two numbers. In fact, SCM and LCM of two numbers using prime factorization method. You see that the first number here I have taken which is 100 and second number I have taken which is 50, and initially I am going to check whether 2 is the common prime factor of 150 or not. So here in this case, it is the common factor, so common prime factor, so it becomes 50 and it becomes 25. So what will happen here? 2 will get, I have taken 2 here and I will multiply this 2 in this variable. Now again, I will check with this value 2's, but here again 2 is not the common prime factor of these two reduced number 50 and 25. So I will consider the next one. I will increment the value of 2 by 1. Now I will check with 3. Now see that 3 is also not the common prime factor, so I will check it with 4. So 4 is also not a common prime factor of 50 and 25. So I will not pick 4, but here when I picked 5, 5 is a common prime factor, so here it becomes 10 and it becomes 5. And here in this case, this 2 will get multiplied with 5. And now the next number which I'm going to consider is that will be here again it will be 5 because still 5 can divide both these. So now in the next step when you reduce this 10 it becomes 2 and here it becomes 1. So now you can see that the recent value which was a common prime factor was 5, and if this value becomes more than either of these two, immediately we have to terminate the process of finding the HCF. And all these three values will get multiplied together and the HCF value will be calculated. Now the question is how to find out the LCM then. So in case of LCM, the HCF which we have calculated, and this HCF, if we multiply this HCF with the by the remaining values during this process, here these two values, if we multiply, these will return the LCM of these two numbers. Now the same logic I am going to implement here. Now you see here in this program's main method, what I have done, I have taken two variables, one a and b for the two numbers, and then I have taken one variable r for the resultant value. And here now see that I have entered two numbers a and b, and I am going to call this function. The function will finally return a value that will get stored in this variable r. Now first of all, see what will be the base case. So the base case I told you, if the recent value which I have considered as the prime factor, if it is more than either of the reduced numbers. So here if the value I is more than A or it is more than B, if it is more than either of the number, immediately I need to return 1. So why I'm returning 1? Because as I have to multiply, so else if if both these values are divisible by I. So if it is the case, I need to make it recursive. So I need to multiply this I and here with get HCF A upon I and B upon I, and along with the value of I. This time I'm not incrementing the value of I. In the previous example which I have shown you, you just see that in the previous I have considered 5 twice because the value of 5 was not incrementing. If continuous in a continuous process we were getting 5 as a prime factor. So if I is not the common prime factor, then only I am going to increment the value of this I. So here in this case, A and B will not get reduced and this I plus 1 will happen. So this is the process here. This is the process with the help of which we can just calculate the prime factor HCF of two numbers using prime factorization method. Here I have not taken scanner class, that's why this error is here. So scanner SS, new scanner, and now this the name of the object is obj find SCF obj. Yes, find SCF was the name of the function was get SCF. Here it is, let it be get SCF only, so that I need to modify it here only. Is get SCF variable obj is defined in the method main. So I have by mistake I have defined declare these object of the class twice. So now it's okay. So here suppose two numbers I am getting, and the first number is 100 and the second number is 50. You can see that the SCF is 50. Another example, suppose I have got the numbers 35 and 15. In this case, the SCF is 5. So it's fine, it's working. And if you want to see that how these A and B values are being generated here, so in that case, I'm just printing all these values. First number is 35 suppose, and then second number is 15. You see that initially 2 is not the common prime factor of these. So what happened, it becomes 3 and the numbers are not reduced. So here 3 is the common 3 is still not the common prime factor. So we have got this value 4. 4 is not, so we have got this value 5. 5 is, so here what happens, it 35 will get reduced to 7, and this 15 will get reduced to 3. And now at this point of time you can see that this I is 5, this A is 7, this I is 5, this B is 3. So if either of the value 7 or 3 is less than 5, then immediately this return will happen. So how many values have we have got multiplied with the help of this statement? Only one value, which was 5, and then when the base case was true, it was 1. So SCF in this case is 5 into 1, which is 5. So that's why the output was 5. Now here in the same program, suppose if we want to calculate the SCF of two numbers using this prime factorization method only. So here I have got LCM, and here the two parameters A, B and C, sorry, here I, A, B and I. The rest of the things will be same. Here copied, and the rest of the things will be same. So here this code is also calculating the SCF. Was I have told you that if in place of the SCF which we have got, if we multiply the SCF by the remaining values, remaining reduced values of A and B, we will get LCM. So it is A into B. If we in place of 1, if we write A into B, it will calculate LCM. So here let us check that how it's working. Here SCF is this, and R is equals to obj dot get LCM A comma B comma 2, and here the LCM is R. Now you see, suppose two numbers I'm passing 35 and 15. You will see that the SCF is 5 and LCM is also 5. So how come it is not correct? Here I have not changed the name of the function. LCM, here it will be LCM, and here also it will be LCM. So now you see here the values are 35 and 15. You see that here LCM is 105 and SCF is 5. need not to print the values here. We have understood how these are being generated and reduced. So if the number is 35 and 15, you see that HCF is 5 and LCM is 105. One more example, suppose we have got 100 and we have got 50. You see that the HCF is 50 and LCM is 100. I hope you have enjoyed this video and thanks for watching.